Okay, so this video is going to go over the Unit 4, Lesson 4, Solving Systems of Linear Equations Graphically, practice day number 2. So this is just extra practice, again, for those of you who finished with the NWEA testing. Okay, so for some reminders, our linear equation formula, y equals mx plus b, where the m is the slope, the b is the y-intercept. And here's our 3 different types of solutions for systems of linear equations. And a system is just when you have 2 or more linear equations. You can have one solution, which means they intersect once. You could have no solutions, which means they never intersect. That would be for parallel lines. Or you could have infinitely many solutions, which would be 2 lines on top of each other. The lines are coinciding. It looks like one line, but there's actually 2 lines on top of each other because it says it's a system. System has to be more than one. So there's 2 lines on top of each other. The solution's every single point along that line, so it's infinite. Okay, so let's go over some vocabulary. Fill in each blank with either the word different or same. A system of linear equations with exactly one solution consists of equations that have blank slopes. So, in order for it to have one solution, they have to intersect and their slopes have to be different. Whenever there are different slopes, you know there's going to be one solution. The y-intercepts, it doesn't matter. They can be the same or different. Okay, a system of linear equations with no solution, like in this picture, when the lines are parallel, they have the same slope. They are rising or falling at the exact same rate of change, but they have to have different y-intercepts. They're starting at different spots on the y-axis. And a system that has infinitely many solutions, like this one here, where you have one line on top of another line, they have the same of everything, the same slope and the same y-intercept, because they're the same line. Okay, circle the equations below that will create a system of linear equations that has exactly one solution using this as the first equation in our system. So, to have one solution, we said that they have to have different slopes, and we don't care what the y-intercepts are. They could be the same or different. So let's see which one has a different slope than this guy. Our slope is -4/3. So who has a different slope than that? Let's see. This one has a different slope. This one has the same slope, so that's no good. This one has the same slope. But this one has a different slope. I'm going to box in our slopes there. Different slopes mean they'll cross one time. These guys have the same slope as our first equation, so they're going to run parallel to it, and they'll have no solution. They'll never cross. Okay, let's find the equations that will make the system have no solution. So we just said to have no solution, they're going to be parallel. They're never going to cross, which means that they have the same slope. Whereas for this one, in order for them to cross, they had to have different slopes. So they have to have the same slopes, but there's something else important too. They have to have different y-intercepts. The reason they have to have different y-intercepts is because if they have the same slope and the same y-intercept, they'll just be the same line. And we're looking for 2 lines that run next to each other that don't ever cross. So y equals 3x minus 1. We need to find a line that has another slope of 3x. Well, this one does not have a slope of 3x, so it can't be that one. This one has a slope of 3x, so does this one, and so does this one. Great. We need the same slope. Now we also need to find different y-intercepts. Is this a different y-intercept? -6, -1? Here, I'll highlight them. All right, so we have a y-intercept of -1, -6, -1, and +1. Has to have a different y-intercept, and it does. So this one is going to cause no solution with this one because they have the same slope and different y-intercepts. Same slope, same y-intercept, that's no good. Same slope, different y-intercepts, that one works for no solution. Okay, and then we have infinitely many solutions. Infinitely many solutions is when you have the exact same line and you end up having two lines on top of each other. So they have the same of everything. Same slope, same y-intercept. Okay, so let's see. Our slope has to be -2. And our y-intercept has to be 5. We have to find the same line. Well, this one has a slope of 1, so that's no good. This one has a slope of -2, and it has a y-intercept of 5. That's the same line. That will have infinitely many solutions. This one we're going to have to do some work on. We need that y by itself. So I'm going to add 5 to both sides. Y equals -2x plus 5. Well, that's the same line, same slope, same y-intercept, right? They both have a y-intercept of positive 5. And a slope of -2. Bingo, those are all the same, right? For infinitely many solutions, we're looking for the same line. What about this one? When we get the y by itself, we get y equals -2x minus 5. Well, it has the same slope, but it has a different y-intercept, right? -5 and positive 5 are different. So that one is not going to create infinitely many solutions. That would actually be no solution because they have the same slope but different y-intercepts. Okay, let's look at some practice problems. Okay, so we have two linear equations. We have a system and we have to graph them and try to find the solution. All right, so for this one, our slope is 1/4, so we're going to go up 1, right 4, and our b is -4. So I'm going to begin at -4, and then I'm going to go up 1, right 4. Up 1, right, 1, 2, 3, 4. Reverse it by going down 1, left 4, down 1, left 4. Whoops, that was only 3. Okay, this was y equals 1/4 x minus 4. Now let's graph the other one. Our m is -1/2, so we're going to go down 1, right 2. And our b is -1, so we're going to begin at -1. Begin at -1 on the y-axis, down 1, right 2, down 1, right 2, bingo, down 1, right 2, down 1, right 2, up 1, left 2. The solution is where they intersect. And I should have known that they were going to intersect right away because I knew they had different slopes. Our solution is 4, -3. Okay. Next one. Our slope is 3, and our y-intercept is -2, right? mx plus b. We need to look at our slope as a fraction so we can figure out how to move. So 3/1 tells us we're going to go up 3, right 1, and we're going to begin at -2. Begin at -2, up 3, right 1. Down 3, left 1. Label it off to the side. Okay, now let's look at our next one. This one is y equals 3x plus 4. So I noticed already that they have the same slope. When you have the same slope, we learned that that means they're going to be parallel and never intersect. So I already know that this is going to be no solution. But let's do it anyway. m is 3. So again, 3 over 1, which is up 3, right 1. And our b this time is 4. So we're going to begin at 4. And then we're going to go up 3, right 1, up 3, right 1. Backwards would be, the opposite is down 3, left 1. They're very close together, but they're parallel. They have the same slope, so they're never going to intersect. So because of that, they're parallel, same slope, so no solution. Okay, let's take a look at this one. Just gonna zoom this out a little bit. Oh boy, okay, these are not in y equals mx plus b form. Right, we need them to be in y equals mx plus b form. We're gonna have to do some work. All right, so we need this y by itself. So to get there, we need to get rid of the 2 in front of it. That's 2 times y, so the opposite is divide by 2. I need to divide everything by 2 then. So now we're going to have y equals 1/2 x plus 4. Because this is a 1 in front of the x, so that's just 1 divided by 2, which is we're going to leave as a fraction, 1/2 x plus 4. Okay, let's rewrite our second one. We need to get our our y all by itself. So we need to move this minus 4 out of the way by adding 4 to both sides. Then we'll be left with y equals 1/2 x plus 4. Interesting. Y equals 1/2 x plus 4. Y equals 1/2 x plus 4. Same slope, same y-intercept. What's going to happen? I start at 4, and then I go up 1, right 2, up 1, right 2. Right? Our b is 4. Our m is up 1, right 2. Down 1, left 2 to reverse it. Okay, so this is my blue line. Label it with the original. So that was 2y equals x plus 8. And then when we go to graph the one in pink, I begin at 4. And my slope is 1/2 again. 4, up 1, right 2, up 1, right 2, up 1, right 2, down 1, left 2. It's the same line. If I trace it in pink now, it's just going to be on top of each other. Label it. This was y minus 4 equals 1/2 x, right? We label it with the original. This is an example where we have infinitely many solutions. It is the same line on top of each other. Okay. Now we have a little bit of creativity on this page. Create a system of linear equations with a solution of 3, 2. Prove it using the grid below. Okay, so 3, 2 is the solution. We're kind of working backwards here. So we know that that point has to be on both lines. So you can make up any line that you want. So let's see, maybe I want to, I don't know, rise 1 and run 3. Rise 1 and run 3. I'm just going to circle that to remember as our solution. So then I would go down 1, left 3. Down 1, left 3. Down 1, left 3. Down 1, left, 3. I messed up here. Hold on. Down 1, left 3. Down 1, left 1, 2, 3. Down 1, left 3. Okay. And I just made that up. I don't know, I just felt like going down 1, left 3. Or well, to start, I went up 1, right 3. So my y-intercept is 1, and I'm going up 1, right 3. So that means my line is 1/3 x plus 1. I start at 1, and I go up 1, right 3. Okay, That hits the point 3, comma 2. Now let's make up another one that has this point. So I'm going to put that point in pink. Maybe now I'll go down 2, right 1. Why not? Down 2, right 1, down 2, right 1. I could go up 2, left 1, up 2, left 1. Whoops. Up 2, left 1. I went down 2, right 1. So that'd be negative 2 over 1, which we don't need to write. And then my y-intercept here, did I mess up again? Let's see. Up 2, up 1, up 2. Yeah, I did. Okay, so when we were going up 2, left 1, up 2, left 1, up 2, left 1, after going down 2, right 1, my y-intercept, you could tell, is 8. Sorry for all the mistakes. So that's a system with a solution of 3, comma 2. Again, we're working backwards. All right, now let's get creative and find a system that will have no solution. So in order for them to have no solution, they have to have the same slope and different y-intercepts. So let's just make that up right now. Same slope. So let's see, maybe I'll make my slope negative 1/2 x. You can make up whatever you want. Different y-intercepts. So this one will start at 3, and this one will start at 1. Let's graph them. Hopefully it works. Let's see. The first one I start at 3, and then I go down 1, right 2. Down 1, right 2. Up 1, left 2. And then my other one, I'm starting at 1, and then I'm going down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. And sure enough, they're parallel. They have no solution. So you can make it up however you want. Just know that you have to have the same slope, and you have to have different y-intercepts. And I should be labeling these, my goodness. This other blue one was y equals 1/3 x plus 1. This pink one was y equals negative 2x plus 8, right? These had different slopes, so they intersected. These have the same slope, so there's going to be no solution. Now let's create one that has infinitely many solutions. So in order for it to be infinitely many solutions, they have to be exactly the same line. So let's see, I'm just going to make one up to start. How about y equals, let's do a really steep slope, like 5x minus 3. Okay, so let's graph that. Start at negative 3. My slope is 5 over 1, so I'm going to go up 5 to the right 1. 1, 2, 3, 4, 5. Whoops, keep messing up. Okay. That's why we should probably use pencil. All right, down 5. 1, 2, 3, 4, 5. Left 1. Okay, so that's my first line. Now, to have infinitely many solutions, it has to be the same line on top of each other. So I could just write y equals 5x minus 3 again, but that would be too easy. So instead, I'm going to say, what if you add 3 to both sides? Let's bring that 3 over there. Then I would have y plus 3 equals 5x. Minus 3 on both sides, we would get the original. So I'll show you. Minus 3 on both sides. You would be back at what you started with. So this is our original that we're going to graph. But in order to graph it, we would have had to move around the plus 3 to the other side and get back to what we started with. So you can kind of play with your equation to find an equation that's equal to it. And then it would be the same thing. We're starting at negative 3. We're going up 5, right 1. Same line. But it's instead y plus 3 equals 5x because I moved the minus 3 to the other side just to be fancy and change it up. But it's the same line. All right, so just as a quick recap, one solution is when they cross once, they intersect once because they have different slopes. No solution is when they are parallel. They have the same slopes but different y-intercepts, never cross. And infinitely many solutions is when they have the same slope and the same y-intercept. So we'll just add that real quick. They're basically this, they are the same line. Same slope, same y-intercept, same line. They're infinitely many solutions because they're on top of each other. Alrighty, thanks for watching our lesson from Tuesday, November 24th. Bye.